In this video, I will explain parallel lines. The basic definition of a parallel line are lines that never meet. They are always opposite to each other and they never meet. So, for example, the line AB drawn is parallel to the line CD. Talking about slopes of a line in equations of straight lines. If two lines are parallel, then they have the same gradient. Like, for example, in this case, if I take the line AB, the gradient of it as m1, and the line CD, the gradient of it as m2, then if the two lines are parallel, we expect m1 to be equal to m2. That's the rule. So we have got some pairs of equations here to prove or to check if they are parallel, and we need to check their gradients. If the gradients is the same, then we consider them as parallel lines. If we start with the number 1, for us to know the gradient of a line, always we have to express in the form of y equals to mx plus c, where m will be the gradient. So in equation 1 already it's in that form, y equals to mx plus c. Therefore you find that the coefficient of x, which is a half here, is equal to the coefficient of x in the second equation, which was a half. So clearly, without doing any calculation, we can conclude that the first pair of equation of that straight line is in fact a parallel line. So when we come to number 2, we have to express that equation in the form of y equals to mx plus c. So we shall take we shall only leave 3y on one side, so we'll have 3y equals to when we take 2x to the other side, we will have minus 2x, and negative 8 to this side will have positive 8. Expressing an equation in the form of y equals to mx plus c means that we should leave y on one side and take the rest of the items to the other side of the equation. So what is remaining here is we divide every side by 3, every term, so that our final equation will be y equals to negative 2 over 3x plus 8 over 3. So clearly here in this case our m1, let's call it m1, is negative 2 over 3. So coming back to the second equation, we have to take everything to the side of the equation except negative 6y. So we'll have negative 6y equals to 4x, because it's negative. So when you take 4x to the other side, it will be positive. This is plus 21. If you take to the other side, it will be minus 21. Now dividing both sides by negative 6, we shall get our final equation as y equals to simplifying that 2 over 3, that's negative 2 over 3 x, then plus 21 over 6. Okay, so finally what we are going to have is a new gradient here also. The gradient of this one, of the second equation, is also negative 2 over 3. Let's call it m2. That's also negative 2 over 3. Therefore the two gradients are equal. Both of them are negative 2 over 3, and therefore clearly what we can conclude here is that the two equations of the straight line are in fact parallel.